Everyone for staying with us and for hearing out this presentation on using BRR with an automated oversize overweight permitting system. I know I'm the last one, and thanks everyone for staying with us. The AASHTO BrR system is a powerful tool that can be used for load rating heavy trucks as part of an automated permitting and routing process. The oversized overweight trucking industry expects state permit offices to be able to self-issue permits that weigh as much as 250,000 pounds. You can see on there that the higher the weight the state allows to be self-issued, the more friendly the color that the SCNRA has put on it. Of course, green being the best and then red being the least favorite. I'm happy to say that 3 out of the 4 green states on this map use ProMiles routing systems. The Federal Highway Administration also recommends that state permit offices adopt automated, oversized overweight permitting and routing systems to improve highway safety and protect infrastructure. And this is the section of that report where that's discussed. Using the AASHTO BrR products, DOTs have provided safe, automated, oversized, overweight routing and permitting for these heavy loads up to 250,000 pounds. BrR is able to load rate 90, that is self-issue, up to as high as 250,000 pounds. BrR is able to load rate 90% more of the typical DOT's bridge inventory. The vast majority of these bridges can be rated in less than a second with the load rating tool. Keep in mind, this is full load rating, not any sort of approximation. This presentation describes how to use the AASHTO BrR system with an automated oversized overweight permitting and routing system. Most of the oversized overweight permitting systems have a permit order process where the industry user enters permit information such as permit type, dimensions, axle weights, and spacings before selecting the route. The user will select the start and the end point for the route. Most systems allow the user to enter an address, intersection roads, or click on the map to identify the start and the end of the route. The automated permitting and routing system will then calculate a route that is safe for the permit. Now, the route calculation is performed while the user is waiting. Since the user is waiting for their route, generally this will need to be done in a minute or less. And it is this time constraint that drives how the load rating is performed in these systems. And keep this time constraint of about a minute or so is what you've got to present the user a route, or they'll consider your system unresponsive. But keep that in mind for the rest of the presentation. Okay, the first step is, first we're going to talk about, provide an overview on how oversized overweight routing happens. First step of this is to build a routable GIS data set for all roads under the permit office authority. Now, this data set must, of course, be routable. That includes one-way directions, turn restrictions, signage, and so forth. The data set must be at the roadbed level. What that means is that dual carriageway roads need to be represented as 2 separate one-way road segments going in opposite directions. Your GIS data set must also include all ramps, flyovers, turnarounds, and so forth that connect the main roads together. Now, after you've built this, so this GIS data set describes where permit vehicles can be permitted. And we've got a little screenshot here of the Denver area in Colorado, and you can see the green highlights on some of the various roads, and then also the green highlights are on some roads that are not displayed at this zoom level. It's those green roads that where the permit can be permitted, travel on and be permitted on. The second step is to identify where a particular vehicle cannot travel. These are described as oversized overweight restrictions. It's these restrictions that are applied to the, will be applied to the roads that the permit office has jurisdiction on. And it's also these restrictions are specific to a particular permit, vehicle, and route. The most common restrictions are vertical clearance, construction, no permits, turn restrictions, posted weight, and other sorts of posted weight bridges and other posted weight restrictions, and then finally bridges that fail load rating. Each of the restrictions that are on this list, which basically is all of them but the load rating, can be calculated virtually instantly. That includes vertical clearance, construction, no permit, turn restrictions, and posted weight bridges. So for example, to identify whether or not a truck fits underneath a bridge is fairly simple. You just compare the height of the truck versus the underclearance of the bridge, as you can see from here. If the truck fits, you're good to go. If it doesn't, then that truck has to go around that bridge. Now, the routing system is generally able to identify all of the restrictions, except, of course, the live load rating that's applicable to a particular permit in the state in less than a second. And the way the permitting or the routing systems work is it identifies all restrictions that are applicable for a particular permit. It identifies all of the restrictions in the state, and then it's able to route from the origin to the destination, avoiding all of these routes. Now, the optimal route can be calculated from the origin to the destination around any restriction applicable to that load in less than a second. Usually, it can be done in a few hundred milliseconds. Now, the last restriction on there, which is load rating, is a little bit different story. High quality load rating is more computational analysis is required. It takes more time. The fastest high quality load rating currently is 40 to 50 bridges per second. And that's using a relatively simple models with a single multi-core server. Now, with more complex bridge models, this can drop to as little as 4 to 5 bridges per second, again, on that single multi-core server. Because of this, rating all the bridges in virtually all states for a particular permit is not feasible. A good solution is to first find the route using only restrictions. And you can see the route starts at the green point here, goes along the blue line to the destination. The red highlights that you see on in this map, those are the dimensional or weight or posted weight restrictions. And you can see that we've routed around those restrictions. Calculating this route only takes a second or two. The second step in this process is to identify the bridges along the route. And you see all the little green check boxes. Those are bridges that are on this route. By doing this, we reduce the list of bridges that have to be load rated from thousands to a few hundred at most. At that point, we can rate all of these bridges that can be rated using the load rating tool. Generally, this will take from a few seconds to maybe as long as 15 seconds. If any of the bridges fail along the route, then the roads that are carried on that bridge are added to the restriction list and we route again. And you can see in this case, we've got a bridge failure along here. And so we ended up routing up north to go around it. We repeat this process until the route is found or the system determines that no routes can be found. Now, the limitation to this process is, of course, the bridge types that cannot be rated by BrR or the load rating tool. And those will not be rated for this load. This was a lot of what Jake was talking about yesterday in his presentation from ITD. Now, the options for these emissions include, first of all, you can identify bridges that do not need to be reviewed until super heavy criteria is met. Every bridge office that we have worked with has identified a subset of their bridges that they have confidence will be able to carry any load short of a super heavy. You can also utilize alternative fast options, including like simple moment comparison, axle weight limits, axle group limits, table rules. ITD also uses the factor as an alternative fast moment. And then the last option is for states that are building out their bridge inventory, but still want to put a automated oversize overweight permitting system in that does some bridge analysis, is they can prioritize bridges. That is, implement models for bridges with known lesser capacity first. Now, several states have successfully utilized the load rating tool to perform load rating on heavy but less than super heavy loads during the routing process. Right, next, we're going to talk about rating super heavy loads. These are a little bit different. The major differences for the super heavy is that in almost all cases, all bridges must be that are crossed must be analyzed. These types of loads frequently use some sort of non-standard gauge configuration. These loads will often require crawl or single lane conditions to pass certain bridges. And most importantly, industry understands, or at least accepts, that these permits will require additional time to analyze. Now, the typical super heavy workflow is as follows. First, we run the route using only dimensional and posted bridge restrictions. Optionally, we can use the load rating tool to identify bridges that fail, and that the better the routes you get on the first pass, the quicker the bridge office is going to be able to approve the load. Now, we'll talk more about using the load rating tool for super heavies here shortly. Next step is to create what is called a bridge study. And that is a programming structure that is used to store the results of the analysis, and it's also used to apply conditions to particular bridges. You know, if you need to add a crawl or single lane or only vehicle on the bridge, something like that, that is all stored in the bridge study. So after you've created the bridge study, you wait for the full BRR to finish analyzing bridges that load rating tool cannot. And then you review the results of the bridge study and identify any bridges that need additional or alternative reviews. Next, we're going to talk for a minute about load rating tool options when routing a super heavy permit. This slide talks about standard gauge loads. Now, the load rating tool, of course, runs hundreds or thousands of times faster than the full analysis. And in many cases, the load rating tool can be used to identify bridge failures during routing to get a better starting route. Now, one thing to keep in mind is that for super heavies, sometimes bridges will be approved even though load rating tool or BRR technically fails the load. Engineering judgment or something else can be utilized to say, yes, that load is safe to cross that bridge, based on whatever particular travel conditions it may add to it. So what that means is that the system should allow the load rating tool analysis to be turned off for super heavies. The reason for that is load rating tool may find a bridge, but at the end of the day, or may fail a bridge, but at the end of the day, that bridge needs to be along the route. And if you can't turn the LRT analysis off, getting that route often will be a bit of a challenge. Now, if you can run the LRT for some of these bridges, the results of that can be stored in the bridge study. And as I said, the load rating tool is significantly faster than the full analysis, and so that will save time. Now, load rating tool also can be configured with scenarios, and ITD utilizes those, and Jake showed some examples yesterday. And these scenarios can be used to identify crawl or single lane conditions that can be utilized to allow the load to pass the bridge. Next slide talks a bit about load rating tool options when you have a non-standard gauge load. In most cases, currently load rating tools should not be used to identify the initial route. The reason for that is load rating tool cannot currently do non-standard gauge analysis. And frequently, if the carrier has a non-standard gauge truck, then on most cases, the non-standard gauge analysis will be required to pass the bridge. Utilizing that special equipment is expensive, and generally the industry will not use it unless they have to in order to be able to cross bridges. Now, one thing I do want to add on this is that if you use the axle weight reduction method for non-standard gauge, and that's ITD uses that. We've got several other of our customers, including Kansas and New York, that utilize that as well. If you utilize that method, then load rating tool can be used for for non-standard gauge loads, because load rating tool does not realize that the analysis is actually used on a reduced weight. So the full BRR analysis uses, like I said, a structure called the bridge study. Once the bridge study record is created, and basically this record is created once all bridges along the route have been identified, the full BRR analysis can start. The full BRR analysis should be in an automated process so that when the record's created, it will kick off. If the vehicle is not non-standard gauge and you've entered it using the non-standard gauge interface, in which And several of the states that ProMiles has implemented systems on, the industries actually enters in the all the tire spacings and so forth. But if the vehicle is not non-standard gauge and we're utilizing that, then full BrR analysis will need to be run on all bridges. And that will take a little bit of time. Once the bridge study is complete, the bridge engineer reviews all results, identifies crawls and other conditions, identifies bridges that cannot be analyzed with BrR, and also we'll go off and do different sorts of analysis or other ways of identifying whether the bridge can pass. And I do want to add that BrR version 7 and above can run all BrR bridge types using the automation. On 684 and before, there were a subset of bridges that had to be run manually. That's no longer the case. Now, this is what the bridge study screen looks like for one of the states. I want to point out, this is for this particular load. This was a permitted weight, 453,000 pounds. These are the bridges that are a subset of the bridges along the route. And you can see on here that these bridges will have different travel conditions. For example, this is 5 miles per hour, the only vehicle on the bridge. This one here is a pass, no restrictions, so that's at full speed. This one here is also a 20 miles per hour, only vehicle on the bridge. And last thing I want to talk about is you look on here for this particular bridge right here, we actually have 6 different scenarios that were set up. You can see on the screen here, we can see the impact and the single lane for each of these scenarios. So the first scenario, we use full impact to 1, single lane is set to no. The second scenario, again, we use full impact, but the single lane was set to yes. And then for each of the other scenarios, we've got reduced impact at 0.2, 0.1, 0.05, and then 0. Now you can see the ratings are listed along here for each of these scenarios. And keep in mind the system will continue or can be set up to continue running the scenarios in order until it identifies a passing condition. It can also be set up to run all scenarios, and that way the bridge office can use their judgment in order to have the least amount of restrictions on the travel for the permit as the bridge will allow. And so you can see on here that for this particular load, we did not get a passing rating until we got to scenario number 5, which was a impact of 0.05 and the single lane is yes. And this is for the state of Ohio, that translates into the condition of 5 miles per hour and the only vehicle on the bridge. Okay, now a summary here. Many states have been successful, or many permit offices have been successful routing heavy but not super heavy loads using the load rating tool as part of this process. Now, this is the steps. Generally, a route is created using dimensional restrictions but not load rating. We identify the bridges along the route using load rating tools. If any bridge fails along the route, then we reroute around that bridge. We continue until a route is found. Most instances, for most of the permitting systems, these permits can be auto-issued. The important thing to keep in mind, of course, is bridges that cannot be rated using the load rating tool. Many state permit offices have also successfully routed super heavy loads using the full BrR analysis using a bridge study. Again, we generate a route using restrictions, and optionally we can use load rating tool or not. Full BrR analysis will analyze bridges that were not analyzed with load rating tool. Full BrR will be used for non-standard gauges. At that point, the bridges are reviewed by the bridge office, and for the results will be reviewed by the bridge office, including reviewing bridges that cannot be analyzed with BrR. And then either the permit is approved, a new route suggested, or the permit is denied. Now, I want to talk briefly about some advancements with the modernized engine. these are really huge things that have been helping in the permit analysis. I'm sorry, in the oversized overweight permitting. First of all BRR types that can be analyzed are now analyzed using the automation. And then also one of the important things is that the full BRR analysis can better utilize servers with a large number of cores. That's 32 or more. This reduces the need for multiple servers in high demand environments. And then finally, we no longer need to run any bridges in standalone basis. In 684, there were some situations where we ended up having to run only one bridge at a time. That was the only bridge on a server. That is no longer the case.